In this video tutorial, I hope to show how we can find the components from a given vector, meaning how can we find those x and y components, breaking the vector down into x and y components from the magnitude and the direction. Remember, all vectors will have a magnitude and a direction, so the vector we'll be working with today is 58 meters per second at 290 degrees. Now this meters per second let us know that this is a velocity, so I'm going to be using v with the arrow on top to represent a vector for this problem. Now the first thing we need to do is to look at our angle. If we go back to our simple coordinate plane, starting at north, we know that this is 0 degrees, and then we go around clockwise, 90, 180, and then 270. So we're at 290 degrees. So we know we're going to be between 270 and then back at the top, which is 360 or 0. So somewhere off in that direction. So in order to complete this problem, we want to know this angle between our x-axis and our vector. So in order to determine theta, all we really want to know is how many more degrees do we have to go from 270 to 290. So it's just a simple subtraction, 290 minus 270, and so our theta is going to equal 20 degrees. And that'll be helpful when we work to break this into two components. Now from this step, I love to draw a triangle because it helps me visualize what's going on in the situation. So we know we have an x component, and a y component, and our vector. Now our vector v is 58 meters per second, and we're going to have a vx and a vy. When the angle here we already figured out was 20 degrees, but this is how this angle correlates. This is when SOHCAHTOA comes in handy. So SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. So let's start with the x component first. So if we're looking at this x component, we look at our angle first and decide if this leg of the triangle is adjacent or opposite. Well, it's very clear that vx is our adjacent and vy is our opposite. Now if we're going to do our adjacent, and we already know our hypotenuse, we can go here and do cosine because we have an angle for cosine, the adjacent value, vx, is what we're solving for, and the hypotenuse, v, that's what we already have. And so when we fill this out, we have cosine of theta is going to be the adjacent over the hypotenuse, or, writing out physically, in the physics terms, vx over our vector v. Now we want to solve for vx, so it's simply multiplying the v vector over in order to get vx equals the v vector times cosine of theta. Plug in our values. And we should get 23.67. Now, units. Because the only unit present here is meters per second, and also knowing that this is a component of a velocity vector, we want to drag those components down, and so that our components will have the same units as our original vector. And so that's vx. Now to solve for vy, we know that this is going to be our opposite. So we have our opposite and our hypotenuse. We also know our adjacent, so we could solve this in many different ways. You could go and do the Pythagorean theorem in order to find vy, but I'm going to go back and use sine for this, just so that we can have experience with doing it with the angle that's given. So I'm going to move the page over so I have a little bit more room to work. To solve for our y component, we want to use the sine of theta, and that's going to be opposite over hypotenuse, or vy over v vector. Now we just want to solve for vy. We multiply v over, so we end up with Vy is equal to v vector times sine of theta. We plug our numbers in. And we should get that Vy is equal to 52.95 meters per second. Once again, carrying that unit about. So, with this vector here, 58 meters per second at 90 degrees, we can break this up into two components, Vx and Vy. Now, Vx and Vy are technically two vectors on their own. However, the subscript lets you know your direction. So our magnitude is 23.67 meters per second, but our direction is in the x direction. Same thing with our y. 52.95 meters per second is the magnitude, and the y lets us know it's in the y direction. So their components are technically vectors, but they're vectors in x and y, in the x and y direction. When we start getting into projectiles, we'll have projectiles and forces. We will have multiple components, and then we can add and subtract in the x and y directions. And so splitting up a vector into the x and y components makes this process a lot easier. But for this problem, these are your two answers. Leaving it just like this, you're good to go.